As you all know, this is a webinar for the Industrial AI Readiness Program. It's a recent initiative launched by NGen here, and it is an IRAP funded program. Just a little background, if we haven't met before, I'm Nicole Rathie. I am a part of the NGen team, as well as support AI for Manufacturing Canada. AI for M is an ecosystem focused on educating and connecting AI service providers and manufacturers across Canada to really understand what industrial AI can do for them. Today, I'll be passing off the floor to Jay and Nick in a moment here to actually go into what the program is. And then we're going to have a little bit of I like to call it a case study pitch of sorts. We'll be going through a couple different case studies by our AI for M members here, really focusing on where this program could actually be utilized on your shop floor, unlocking the art of the possibility, and really running through some great Canadian success stories there. So as you can see, we'll be joined by Maya HTT, Agyle Intelligence, NTWIST, M2M Tech, and we'll wrap it up with Mode 40. And then we will also have about 10 to 15 minutes if everything goes on schedule for a Q&A at the end. So without further delay, I will pass the floor off to Jay and Nick to dive into the project here.
Thanks very much, Nicole. And let me first of all thank Nick and the IRAP team for all of their support here. The idea behind this pilot program really came from some of the insights that we've gathered at NGen about successful implementations of AI in manufacturing. And that really builds on, I think, a lot of the use cases, a lot of the experiences as well of our AI for M cluster, the group of AI service providers that are focusing on accelerating the adoption of AI in manufacturing and industry in general. And very simply, the first observation is how complicated this process is. It's not just simply, well, first of all, it's certainly not buying an AI package off the shelf and then using it in a production system here. And it's much more than the development and training of AI models and algorithms, and certainly not large language models either. It really is a complicated process of integrating AI applications, AI models into physical systems, into production systems, or in embedding AI in physical equipment. And of course, that requires sensors, it requires probably robotics, automation systems. It requires usually vision systems for quality control, segregated networks. It requires cybersecurity along those networks and to protect the data, protect the equipment. And it also requires edge computing solutions that enables real-time analysis, data analysis, real-time control of physical systems. So regardless of how you want to deploy AI, and there's certainly lots of benefits, the use cases that we have that have been generated by the members of AI for M certainly show the benefits, the productivity and improvements, the improvements in throughput, the improvements in reducing downtime, equipment downtime, improvements in quality, improvements in energy efficiency and energy management, carbon reductions, and so forth. There are certainly significant benefits that come out of a successful deployment of AI in manufacturing systems. But it is not a simple process to do that. So in discussions and reflections with all of the members of AI for M, as well as with our colleagues at IRAP, we proposed the development of a new program that would simply provide funding to smaller manufacturers that would help them undertake and work with AI service providers to undertake an evaluation of their readiness to deploy AI in production systems, and to develop implementation plans for that deployment. I think it's important just to help companies understand what the business requirements are for successful deployment. I mean, this goes back to a number of studies that have shown that while everybody is interested in AI, that it is much more difficult to actually deploy AI to meet business objectives along the way. And a part of that is understanding the potential of AI, but also the business requirements for successful adoption, the skills requirements, the data requirements for successful adoption, the governance, the management requirements as well, and the implications of AI for manufacturing strategy, for improvements in manufacturing process as well. So it's with that background in mind that we made that proposal to NRC-IRAP. We were very, very fortunate to get their approval for this program. It's a small program. The idea is to provide $15,000 to manufacturers to pay the professional fees incurred in working with AI service providers to do their AI readiness evaluations and develop implementation plans. But of course, there are two much bigger opportunities here. One is that if this small pilot project is successful, that we will, I think, be in a good position to be able to attract even more funding for this type of initiative. But of course, the second and probably even more important part of this is that having a good strategy for AI readiness and a good plan for AI implementation in manufacturing systems is going to help companies make good decisions about the investments that they're making in AI, and also making good decisions or enabling those companies to find other sources of investment or potential funding from other sources from government, including IRAP itself. So a small pilot project. We're looking to expand the project over time, but we're going to start off with 10 companies, small companies that are IRAP compliant. And as I say, if this works, we will be able to help those companies develop better implementation strategies, but also expand the program beyond that, and be in a better position to help companies actually implement and find the funding in order to do that. So that's the intent. The idea would be to work with AI service providers, largely members of AI4M, that have use cases, that can show the use cases that manufacturers are interested in, and to quickly be able to find partners for manufacturers for successful plan development. So again, thank you very much to IRAP, and I'm going to pass it over to Nick Dimitrov from IRAP itself to give a little bit of background, but also some comments from the IRAP side. So, and thank you,
Jay. No problem. Thanks for all the things that you said about the program. Anyway, my name is Nick Dimitrov. I'm an industrial technology advisor, part of the cross-regional team in Ontario. It's a pleasure to be here and start this program with NGen. I'm very pleased that IRAP is collaborating with NGen, who has a proven track record of delivering national scale funding programs, which is a great benefit for this program, where we would like to create a national impact and connect eligible SMEs to NGen vetted AI solution providers. And that's, I think, the true benefit of this program. That search process where SMEs are trying to find a solution. There's none of the shelf solutions at the moment. They'll be connected with industrial AI providers right from the beginning, and they'll be helped through the process of assessment and eventually create a capable implementation plan that not only addresses the business, but also the technical aspects of implementing that solution in their production process. And the key here, two keywords is manufacturers and production process. So this program is more geared towards manufacturers and their production processes. How can they implement AI solutions within the process? As Jay said, the program is fairly small. It's only $15,000 for assessment and implementation plan, but it does come with recommendation from the ITAs, and ITAs, they have their own budget. So eventually it could grow to a full project funded by IRAP. Based on the success of, I call it like a pilot program, Jay and I agreed that we will work in the future to expand it and make it bigger, but it will obviously be dependent on the quality of the assessments and the projects. So I'm again very pleased, Jay. I worked with you. You're a very capable team. I'm looking forward to the success of this program. Thank you.
Awesome. Thank you both for that background and overview. We'll jump right into sharing some case studies, and then we'll go to the question and answer period at the end. I did just want to note, because we've had a few questions, this session will be recorded. My mistake for not mentioning that earlier. As well, I put the link to the program on the website in the chat there too. But let's dive right in. Rémi, I'll pass the floor off to you to take us through some Maya examples.
Absolutely. Thank you, Nicole, and thank you, Jay and Nicola. It's very nice to be here today. You can see my screen. We're good? Excellent. So I will just in 7 minutes just give you a few samples of potential industrial AI applications that my HCT has delivered. Overall, there's 200 to pick from. So if you've seen me on webinars or other things, you've probably seen some of those, but I will dive right in. So the first one is a machine vision. So leveraging AI from a vision standpoint with robotic components to look at the defects in real time for the manufacturing of composite parts in this case. So even though it's robotics and it's actually kind of automated to a certain extent, the robot may not realize that the element is heating a bit too much and the resin is like splashing all over, or that the tape is twisted. And so there's still defects that are generated even from a pure robotic standpoint. So instead of building 40 to 60 layers of material and then having to throw the part away, what we can do is pause the robotic system, adjust the parameters, get the technician to locally, essentially repair the defect, and then move on from an automated viewpoint. So the AI-based machine vision combined with the real-time telemetry fed into that program to pause the system and alert the technicians. That's one example. Another one is looking at mineral as they come in, for the manufacturing. So based on the amount of spodumene in a rock sample, you can decide to go one manufacturing kind of process versus another, and the cost between the two is significantly different. So to optimize that cost in real time, we can evaluate using high resolution cameras and ultraviolet camera which of those systems, which of the process should proceed moving forward. So that's an example where we've essentially combined ultraviolet imaging and real images, high resolution images, to be able to characterize the amount of spodumene in the system. As you can see, green is where you detect the spodumene. There is spodumene. There's always in all AI projects, and industrial AI is no different. You have false positive and false negative that you need to account for. So the blue is the false negative in this case, and the red is the false positive. On purpose, in this case, we have biased the model to be 50-50 on the false positive versus false negative in order to characterize properly the entire specimen. So from that perspective, depending on the business use case, we will tailor the AI model one way or the other, but there will always be false positive and false negative that need to be taken into account in industrial AI project. A very different scenario here with Agyle Hydraulic. They produce essentially those hydraulic systems for, think of garbage trucks and bigger, more heavy-duty type of hydraulic systems. The number of permutations, and for some reason, every city has a different truck and different system onboarded, so you can imagine the number of different systems they need to manufacture. But in their case, the permutations on the choice of the design for manufacturing and the manufacturing itself can be hundreds of millions of permutations. Now, of course, they have not designed 400 plus million different hydraulic systems. They produce a very subset, kind of component and assembly of this. So what we've created here is a system that will pick the right parameters for manufacturing and ensure that the manufacturing itself can proceed using all the drawings and the other components that come along with it and the quote to the client. So it does a dual kind of approach here, both design for manufacturing, first time, good to go on the manufacturing side, plus the proposal for their client that can churn very quickly. So two benefits from the AI model here. Now we go into production and productivity for quality, in this case, pulp and paper. What we did there is take 600 parameters in real time, convert those, and predict 20 quality parameters to make sure that they stay within spec at all time. It's including 40 control points that we can manipulate and send back those set points, new set points in near real time. In this case, there are still humans in the loop for the big machines with the big levers and everything. So those components would still, every 5 minutes, the technician would get in action at various stages of the manufacturing. So we still leverage human in the loop in this case. And the last example is the telemetry from the mining system. So we look here at bolting patterns where we can figure out the bolting sequence in real time using pure telemetry and make sure that we properly characterize the bolting sequence in that pattern. So that's McLean Engineering. That's a joint project with Maya. I think I'm essentially 7 minutes on the nose. I know it's real fast, but Maya Shiti is there. We have 200 projects, and we're part of the of course, AI for Manufacturing in Canada group, and hope to help you guys adopt AI moving forward.
Awesome. Thanks, Rémi. As well, I want to note we'll be sharing the slides and sharing the case study shared as well today with everyone. David, I'll pass the floor off to you to take us away from PEI.
All right, sounds good. Let me just bring up this presentation for you. Not quite as fancy as Rémi's there. Great job, Rémi. Really interesting stuff. So we're going to focus on Agile Intelligence here. Founder and CEO Dave McNally. We've been at the game since 2017. I've been in the space since 2003, just to date myself. We were fortunate early on to be recognized as an artificial intelligence company by the government of Canada back in 2018 for the cognitive enhancement that we provide our companies. So we work in a lot of cases with people to make sure that there's reliable data being fed into their systems, and also connect to sensors and other opportunities too. So we'll walk through some use cases with you here. So I always like to start my presentation with somewhere something incredible is waiting to be known, because you've all got some data. You've all got excellent information sitting somewhere in your operations right now, and it's just a matter of utilizing AI and other tools to be able to tap into that information and expose it to you so you can make some better decisions and improve your quality and your productivity. Some of that better decision making can have incredible results. We do a lot of work. Our first client was Eden Valley Poultry. If you've been to any of my presentations, you've certainly heard me talk about Troy Lenahan and his team down in Berwick, Nova Scotia, and some of the great results that we've had with them. They're recapturing about $1,000 in operational waste for every operational hour that they're running right now, leading to about a $2 million annual average run rate of waste savings and recapture, utilizing Agile Intelligence in conjunction with some of their other systems that they have throughout their operation and their entire value chain, might I add. So they utilize, skipped ahead there. They utilize the the product from the time they get going in the morning to do forecasting and planning and production scheduling, all the way through to monitoring their quality, their defects, their downtime, and all kinds of other use cases. There's not one area in their operation where we're not touching them right now. So what does that mean? Well, as of February 2026, Troy was kind enough to share some of this information in a collaborative presentation we did at the LeanCon event, hosted by the Institute of Operational Excellence through CME Nova Scotia back in February. They're averaging about 100,000 form submissions a year, where they're able to tap into that information and derive insights from their team. Those forms could be a few questions long, they could be hundreds of questions long. They use that information in order to collaborate and correlate that with the other systems that they're using throughout their operation. So generating just over an alert a day to drive their team. Many of their production managers will tell you they run their day based upon the information that's being received from Agile Intelligence. They have about 164 plus forums that are live throughout their operation, where their team could go to. They can enter information to complement any HMIs, to complement any other processes that they're doing to advance the productivity enhancements that they're looking for. But this is the one he loves the most, is the fact that they now have access to just about, and probably over at this point, 6 million answers, right? It's not about data points, it's about answers that they have in their system that they can run through AI, that they can run through Agile. When they have a question about today, when they have a question about right now, or if they have a question about, a historical event, the answer is there for them. They just need to go and find it. And it's very quick for them to find it on Agile or utilizing some other AI to be able to pull that information out versus have to thumb through, spreadsheets or whatever it might be. So why is this acting up for me? You have to forgive me. I got an eye issue going on here. So it is a cultural tool, and it is spread throughout every department. We all talk about culture. Few tools can actually deliver culture, but down there, they're able to spread it through every department, and not just at Eden Valley. With all the customers that we deal with, it builds resilience and a lean culture that's focused on improvement, productivity, and excellence. And we all certainly want that. So some of the results from that is they've been able to, 10 basis points or better, improve their quality across the industry. You look at the red line here, that's the industry average. Eden Valley for years is always above the industry average with their quality. That's better throughput, that's more productivity, that's more value. Downgrades, that dirty word, where it's lower value, it's higher waste. They've consistently been percentage points ahead of the industry average there as well, utilizing this information. They could take that information, build themselves reports that are more meaningful, that are more impactful when they're talking to their teams. So they're able to highlight specific reasons and have more engaging conversations to eliminate the finger pointing games. It's just based upon simple forms in some cases, or we can also tap into sensors. Now, I privatized some of the names for this customer, but we can also tap in and utilize sensors to pull information forward, to show management across. This is a multinational company that is utilizing the information to be able to capture specific counts for exact time on the line, for productivity enhancement for some of their employees, and incentivize them with that information. So it can be very impactful from that perspective. I like to say as well, though, digital transformation, AI, digital transformation, it's not about the technology, it's about the people. I know there may be some on the call here that would argue that point, but still, we need the people involved. We need the people to make sure that they understand how to utilize the systems and how to complement the systems in order to drive the value out of it that you're looking for. So that's really all I got to say today to try and wrap it up in, which is tough for me in 7 minutes, but, feel free to scan the QR, connect with me on LinkedIn, my email, my phone number, and all that information is there, and happy to answer any questions you might have along the way. Thank you so much to everybody for your time.
Even under 7 minutes there, David.
Wow. Nobody's going to believe that, Nicole.
Awesome. We'll move right along. I'll pass the floor off to NTWIST here and take us away.
Perfect. Thanks, Nicole. I hope you guys can hear me okay.
Yeah.
All right. Hey, good morning, everyone. I hope you guys can see my screen. Yeah, I'll start with a quick brief about NTWIST and what we do. So at NTWIST, we're making a manufacturing platform for optimizing manufacturing operations, the full end-to-end operations within your plant site. Our goal is to empower people through data-driven solutions, and we want to unlock a total of $1 billion in inaccessible value for the manufacturers in North America. And while doing this, we want to have an impact on the environment and reduce the carbon footprint as well. So far, we've been able to deliver $17 million in annually recurring profits across all of our customers. We're currently a team of 36 people, and our specialty is combining and having expertise in both industrial AI as well as the domain expertise, and that's what we combine together in order to deliver this value. And we're proud to say that currently we have 0 customer churn. So before I go into the case studies themselves, I want to quickly talk about the process, the journey that we take with our customer in order to achieve that value. So it always starts with data collection, and this is an ongoing process. Even once we've deployed the solution, we're continuing to collect the data. Once we've collected that data, there's analytics that happens on top of that, and that gives us, tells us the story that the data is telling. Once we understand that analytics, then we can start generating some predictive models. And effectively, this is like creating a digital twin of your operations. So we're wanting to understand what the actual data is saying, and then based off that, we're making some predictive models to say, okay, this is how we can simulate what's happening in your operations. Now, once we have a digital twin of your operations, we're able to use that to do optimization and prescribe to you the optimal action that should be taken based off of your company's objectives. Now, this is a feedback loop process. So once we make that prediction, then we want to, again, be connected into your systems, be able to collect the data, and then the whole process starts again. So I'll go through 3 case studies, what we've done so far. So the first case study is with a multinational global food and beverage manufacturer. And they manufacture cake mixes, powders, and so on. What the problem they were having was with visibility. They were not able to see very clearly or have confidence in the production because things like changeover time, production time, cycle times for actually manufacturing the items, all of this was kind of assumed, and there was no concrete way to fully know. What we were able to do is take in all of their historical data based off of their production, as well as some of the core properties of the food itself, like does it have fat, does it have soy? And based off of this, we're able to predict a much more accurate cycle time as well as changeover time, processing time. And if you think about, let's say, going from in a mixer, if you have to go from a chocolate powder to a vanilla powder, that takes a lot longer to clean than going from a coconut powder to a vanilla powder. So once we have predicted these accurate times, then we're able to optimize and tell them what's the best way to actually execute the production in order to reach their demand. What we've been able to do is achieve almost 30% more throughput. So in the same period of time, they're producing 30% more items just because of better planning and more machine uptime. They are very confident in their on-time in full delivery, which is now at 95%, and they saw an ROI within 45 days. The second case that I'll talk about is an oil and gas field service provider. And again, The platform that we're making, the approach is the same. So same with this manufacturer, we took all the historical data, did a lot of predictions, modeled their entire operational environment. The additional component that we considered here was that all of the different departments, they were slightly disjointed. So procurement is not 100% aligned with what production needs. Same with sales, they're not fully aligned with how production is capable. And even having the unknown about exactly what will happen in production, that slight unknown is what creates a lot of issue between procurement, sales, and so on. So what we were able to do is, because we are able to accurately predict as well as suggest what the best way to produce is, and within this, we're also considering what we call as buffers and risk. So we're predicting the chance of failure for a part, and we're adding a buffer in so that the actual delivery date is truly reflective of what is 100% capable. And same with procurement, we're starting to consider, okay, this is the hit rate of your vendor, this is how accurately they are bringing you the material. And all of these moving components in the operations, we're able to consider them, predict for them, and then create the buffers and assess risk when we make the prediction and recommendation about how to produce. So from this, we were able to achieve a 30% capacity increase. Their full project timeline for a single customer project used to be 73 days, which we brought down to 40 days, and $2 million plus of additional revenue. The third case study that I'll talk about is a turbine maintenance and overhaul shop. So what they do is they get the turbines in, they disassemble the turbine, they look at all the parts that need repair, replacement, and then they execute the production. One of the hardest parts of this type of an operation is that your demand is somewhat unstable. You don't know exactly what you need to do until you open the turbine up. And so that component of accounting for risk or accounting for multiple possibilities of what might happen in order to say that this is with a 95 plus confidence, I'll be able to deliver at this point. That prediction is what we were able to do for this manufacturer. We looked at all the historical data. We looked at the frequency at which certain items or how much the demand shifts by. We're doing that demand forecast. And then we were able to, again, prescribe the production as well as procurement schedules. And what that's done is generate a 2.5 times increase on their on-time delivery. Their total production, what they were doing, shrunk by 132 days. So the entire demand, we're completing at 132 days faster, which means 46% additional jobs in the same period of time. And that added up to a total of 3 million annual opportunity. So the core concept here from a platform perspective, what we're providing is creating that digital twin, predicting for all of the moving components, being able to recommend that action, and then observing and continuously improving our model's understanding of what worked, what didn't work, and then that improves the future recommendations. Would love to connect with anyone. Thank you, guys.
Awesome. Thank you so much. Moving right along, I'll invite Eric up and to share more about M2M.
Yeah, sounds good. Thank you. Just give me a moment. Let me share my screen. Okay, is my screen visible? Yep, okay, amazing. Yeah, so my name is Eric. I'm with M2M Tech. For those who don't know, M2M Tech is a physical AI company. We're focused on deploying AI intelligence for real-world applications. So We work across a variety of different ecosystems: manufacturing, agriculture, energy, healthcare, and defense. And whether it's on-premise or on-site, our platforms aim to solve some core operational challenges, whether it's like reducing downtime, maximizing quality, optimizing energy use, etc. So today I wanted to share one of our recent deployments within the manufacturing space of exactly how AI models can be implemented on the factory floor. So just to provide some context, we worked with a blueberry farm near Maple Ridge, which is like a small city in Vancouver, BC. And we essentially implemented some predictive maintenance solutions for their conveyor belt. So in manufacturing, a lot of mechanical failures, they're traditionally handled reactively, right? When something breaks, everything stops and engineers need to fix it. But if we're able to implement an end-to-end edge monitoring solution, we can take physical signals from the conveyor belt and turn them into real-time alerts and actionable insights. So going back to what we talked about here, when it comes to...
We're just seeing the main slide still.
Oh, same.
Sorry, sorry to interrupt.
Is this better now? Okay, sweet. Yeah, so when it comes to the cost of reactive troubleshooting, right? Whether it's a single mechanical failure, in this case here, we're measuring the performance of bearings. An issue like that would completely halt the primary production line. So that would lead to 1 or 2 full days of unplanned downtime. And then in the middle of harvest season, that could result in like idle labor and high emergency repair costs, right? So what we're trying to do is essentially monitor the equipment, catch any sort of small deviations before anything fatal actually occurs, right? So just going back here, we have our 4 main objectives: eradicate unplanned downtime, shift to planned maintenance, deploy our edge hardware solutions, and then enable data-driven workflows. So in terms of the end-to-end architecture itself, we broke it down into 4 pieces. Layer 1 is sensing. So that would include our custom-built physical sensor nodes that we engineered to sit right up against the conveyor belt's wheel bearings to track things like vibration, temperature, and rotation speed. Layer 2 is our edge hardware. So we have something called the MIA Spark, which is a processor dedicated alongside other extension analog modules. So this box can basically handle all of the local ingestion, computation, and tracking all in one. Layer 3 is our physical data pipeline. So it takes raw high-frequency waveforms and pre-processes them locally on the edge. And lastly, layer 4 is our application layer. So this is our client-facing UI that can convert raw voltages into dashboards for things like administrative SMS or alerts. So here's a closer look at our device itself. Like I said, this is the MIA Spark. So at the very top here, labeled with all the plugins, this is our entire unit. So, and the reason why we do this is because we are trying to implement solutions that can shift away from cloud connection. So this means that all of the logic and data is localized and performed on site. So next to the right of our Spark module, you can see two analog modules. So the reason why we separate these is so we can handle different data stream frequencies without creating any sort of bottleneck. And then this part here, the industrial power distribution, it's a robust heavy-duty power supply that can provide, power. It can prevent any sort of electrical noise, spikes, or drops from interfering with our data collection. So when it comes to engineering the solution, one of the biggest challenges was balancing bandwidth and processing power. So vibration signals from the bearings, they generate massive amounts of high frequency data that could choke a standard network or edge processor. So we implemented a dual track edge processing pipeline where track A is handled by analog module 1. It handles the high frequency vibration streams. And then for track B, it runs on analog module 2. It handles the low frequency streams, specifically the temperature and rotational RPM. So that way, when we run track B, it operates on a slower processing cycle, and it can optimize local edge computing power. So as for the kind of fitting itself, we basically made custom mounting brackets, and then these were constructed out of black anodized metal, engineered to latch directly onto the existing frame. We also have our direct mount sensor nodes, which can sit flush against the bearing housings. So in terms of the entire lifeline of how a predicted failure would typically work, we broke it down into 4 phases. So during phase 1, everything runs at the normal conditions. Phase 2 is where a system provides its biggest asset and value, which is in mechanical stress. So typically, we aim to project ourselves weeks before a failure. We try to look into the microscopic defects in the bearing and look into the high frequency vibration anomalies. And then our EMEA Spark can detect these micro anomalies while the temperature and RPM metrics might still look completely normal. And then this is where our system can open the preventive intervention window. So if that's ignored, we enter phase 3, which is talking about thermal escalation. So maybe days before a failure, friction could cause a pronounced temperature spike. And then phase 4 is seizure, where the wheel bearing would structurally fail. RPM drops instantly to 0. But by combining the data that we collect, vibration, thermal tracking, and RPM data, we can spot mechanical stress weeks away. So ending off, essentially talking a little bit about the big picture behind what we do. We create edge devices to gather more operational intelligence. So first is compound insight through multimodal data, right? So tracking things like vibration, temperature, speed. We can eliminate false alarms and, more importantly, accurately pinpoint true mechanical degradation. Secondly is rugged independence. We have a fully deployed non-invasive sensing architecture that can operate in an environment without interfering with the production of factory electrical systems. And then third is projected margins. So we empower farms such as Twinberry Farms to shift away from these costly emergency line stoppages and instead move into a controlled scheduled maintenance window. So that was a little bit about us, and thank you for your attention.
Awesome. Thanks, Eric. I know we do have one more panelist. Unfortunately, they're having a little bit of technical difficulties, so if they hop on, we can pass the stage off to them. But for now, let's switch off to the questions. I know we've had a couple come through. Eric, I know there's one question directed for you here. Let me just see. Can you comment on the cost of implementing a similar system for conveyor belt failure monitoring? Do you have any intel on that?
Yeah, so for something like this for the finances, I'll need to double check with my team for the final cost. I was more so just like responsible for the engineering side. But I can get back to you.
Awesome. Perfect. And I just see Tracy hop on there. So Tracy, we'll pass the floor off maybe for 5 minutes on Mode 40, and if you can share 2 case studies and spark the art of the possibility for the program and what you guys can do.
Yeah, sorry about that. A little bit of miscommunication on our end. And so tag I'm it today. Good morning, everyone, or good afternoon, depending on where you're located today. My name is Tracy Gromniski. I am Chief Product Officer and Partner at Mode 40. art of the possible when it comes to manufacturing and AI. Really, I know we talked earlier, presenters talked about quality, and I think one of the things that I'll focus on in the case studies will be on continuous improvement and anomaly detection and data acquisition and monitoring that data. So when we go in and we do connection of machine data, we usually do it via sensors or through the PLCs. And we've done a significant amount of work where certain customers that we've implemented, we've been able to do predictive maintenance based off of vibration data coming off of the machines, or increased in voltage usage, or other detections that we have agents monitoring over time as they collect that data to surface any of those anomalies. So you can go in and do early investigation and then hopefully prevent any downtime. We had a client who was having issues with some of their hydraulic pumps, and we noticed that we could do early detection of seal replacement when we were looking at PSI and oil pressure going through the hydraulic lines. And so because we were collecting that data and running it through an anomaly detection agent, we were able to do early prediction on replacing hoses and replacing seals so that there wasn't failure and then having to do hold on product on the line. Some other areas were also in detection of filling. And so in the food and beverage industry, we look very closely on minimal allowable variances. So tolerances when you're filling containers or product. And one of the areas that we've applied AI has been to do detections and pattern recognition on whether fillers or extruders were maintaining within the packaged minimum allowable variance. And one of the biggest things is one of our customers was able to have tighter variances because now they were not human managed and they were managed using the data directly off of the machine, and then connecting that to the PLC to allow for adjustments, where the giveaway was actually reduced and quantified over 18 months, about a $3 million savings in which they did not provide giveaway. And so that was another way that we've been able to use machine data and data collection to empower the manufacturer to find value and savings within their manufacturing facility.
Thanks so much, Tracy. Perfect. Well, now we'll move along. I know there's quite a few questions in the chat, and I've started to answer a few, but why don't we jump in here? If anybody has any questions, now is the time to also put them in the Q&A or the chat. A question we're getting often here are how the 10 SME are selected for this program. First step is doing the EOI on the website. I've put it in the chat here. From there, we'll have discovery calls and assess the readiness and connect the dots from there. So I do suggest you reach out to us here at NGen. I'll put myself and Frank's email here in the chat, as we'll be running the program on the NGen side.
Nicole, I just wanted to add that I think what will be important is to be nominated by one of the industry technology advisors from IRAP. So companies need to have that nomination from IRAP as well. And the application is open here, and Nicole has provided that to everybody. But we will be, given that we only have 10 spaces here for this pilot project, It'll take us a few weeks to receive all of the applications, to take a look at making sure that that we do have the recommendations coming in from IRAP, and that will lead to the selection of the manufacturers there. As I said before, this is just a pilot project. If it's successful, we'll be expanding this project, so it's not. You may want to take some time to look through the application, to think about what you want to do before actually going forward with an actual application to be part of the project, because it will expand over time. We're just looking for the initial 10 companies.
Yeah,
I just wanted to add to this one, to Jay. It's definitely, it's not a competitive process, but we're looking for good projects and good applications. Obviously, the ITs play a key role here. If your client is ready to submit an AI project, please do so and cover as many of the angles. The form that NGen going to present is really straightforward and down to the point, and we're looking forward to see the applicants.
Awesome. I might also have some of the panelists jump in on this question here. Where was it? Oh, here it is. For the AI PDM capabilities presented by the panelists, are you integrating the CMMS EAM systems for auto work order generation, or just limiting to maintenance alerts? More of a technical question there for our panelists. Don't be shy if anybody wants to jump in there.
So from a Mode 40 standpoint, when we do integrate with CMMSs and EAM systems for auto creation, but we also tend to practice human in the loop. And so there's going to be like auto generation, but verification and notification, because not every anomaly or issue that AI may detect or through the workflow, there's still that human in the loop practice that is still should be required as these systems mature, and they don't always have the context. And so those capabilities do exist. I know from the implementations that we do, and I know like other companies have as well.
Awesome. As well as we have been receiving a lot of questions about the AI service provider and having one selected. You do not need to have one selected. Part of AI for M's supporting role is also helping you actually understand who is in the Canadian ecosystem and how to get connected with them there. If you do have a service provider you're already working on in another project or know of and have a relationship there, you can list them in the EOI. The qualification to be a service provider is having a case study on that use case explorer that Jay mentioned earlier. So again, reach out to me and we can get them up to speed there.
And Nicole, maybe sorry, I just maybe it'd be useful just go through the process here that we're thinking of. When you submit an application, when the manufacturer with the reference from IRAP submits an application to us and basically tells us what they want to do in their AI implementation, then we will farm out those applications to those companies with use cases, applicable use cases on the AI for M platform, and companies can then the AI service providers can then apply to the manufacturer to suggest that their solution would work for the manufacturer. It'll be up to the manufacturer then to approve or to select the AI service provider that they want to work with, and as soon as that's done, we'll be able to then proceed with the project itself. So we want to make sure that manufacturers are able to select the AI service providers. The funding, and this is another question there, but the funding will go to the manufacturer to pay the professional fees charged to them by the AI service provider for the AI readiness assessment and the development of an implementation plan.
Yeah. I just want to add to that, Jay. This is very simple model based on the request for proposal model. So request for proposal is issued, which is the SME. NGen will do the matching with the industrial AI provider, and they will respond to that request for proposal, and then the process starts.
That's right.
JD,
I just see another question there. Can they? So we will cover the professional fees charged up to a maximum of $15,000 there. So there's no matching required by the manufacturer itself. It's a simple coverage of the up to a maximum of $15,000 of the fee for the evaluation and the development of the implementation plan. I think there was another question too about whether or not it would cover change management and training. So this is not a fee to actually cover the expenses of the implementation. It's a fee to develop an evaluation, basically to identify the business requirements for successfully adopting or successfully applying an AI solution to the problem that manufacturers have. What is required to do that? Is the manufacturer ready to do that? And then the development of a plan, which may include training, it may include change management, may include the requirements for data improvement of data systems, and so forth. That would all be part of the evaluation and the plan, but the money would not go directly to skills training or to the implementation of the project itself. That would continue, or that would come after the implementation or the plan has been developed.
Perfect. Just as we have a moment here left before the time is up, I just wanted to remind everyone that this session was recorded. I know some have hopped in halfway. Please reach out to us if you have any questions. We'll share the recording. We'll share all of the panelists' information as well. I just wanted to have Jay touch on one last thing about the timeline of this program, because I know we had a couple questions that I don't think we've answered that yet.
Sorry, thanks, Nicole. So the application process is open now, and you can apply through the website. We want to make sure, and I'm sure that we will have lots of applications coming in. We'll take a look at good projects, make decisions really quickly in terms of the manufacturers participating in this pilot project. We'll do the matching with the AI service providers. They're making sure that there's a match that's complementary, and that the participating manufacturers are okay with the selection of the AI service providers. I think it would be a very easy contracting process. It's pretty straightforward, it's pretty simple, just in terms of paying for the professional fees incurred by manufacturers with their AI partner. And we imagine that the project itself would be a fairly quick one to implement. Here, a matter of days to do the evaluation, maybe a little bit longer than that to develop the plan. But we would like all projects to be wrapped up by the end of December. That's kind of the timeline for this. With a report back, not necessarily specifying the details, but a report back talking generally about the types of requirements that the companies would need to be able to undertake, and the types of issues that they need to resolve in order to undertake these projects.
Awesome. Perfect. Thank you, Jay. And thank you to all of our panelists as well for joining. I know we have a couple of questions left, but I'll put them in the email follow-up with some answers there as well. Thank you all for coming out today, and looking forward to seeing all of you through the EOIs and in the program soon. Have a great rest of your day.
Thank you, everybody.
Thank you.
Thanks, everybody, and thanks again, Nick.
You're welcome. Thank you.